Hello, my name is Mark Anderson. I'm an applications engineer with CamLogic. I'd like to spend some time with you today going over what's new in Solid Edge ST8. First, let's talk about CamLogic. CamLogic has been in the CAD, CAM, and CAE space for over 35 years. The company was established 19 years ago, initially focused on serving mainly the tool and die shops in the area. As the market has evolved, CamLogic has evolved, interestingly working our way backward from manufacturing to the conception of the idea or design. Because we started toward the end of the process and worked our way to the beginning, CamLogic has the fundamental knowledge of what has to be done to assure that each step of the process will result in a product that will actually work or fit into the next phase of development. CamLogic has become a leader in engineering and manufacturing industry, providing software and hardware solutions, bridging the gap between the issues and the solutions with a highly trained application team. Strategic partnerships and certifications with recognized vendors provides CamLogic's team the ability to offer state-of-the-art tools and solutions that enable our customers to fulfill the full cycle of product development. Our technologies include 3D scanning, CAD, CAM, CAE, PLM, PDM, 3D printing, rapid prototyping. CamLogic employs a three-legged stool strategy. We partner with Siemens, offering the complete integrated solution portfolio for design, manufacturing, analysis, data storage, and retrieval. Additionally, we have a new partnership with Zuken, whose leading-edge software used to optimize the electrical engineering design and is fully integrated with the industry's major MCAD solutions. We also sell and support 3D color, plastic, and metal printing from both 3D Systems and Envision TC for rapid prototyping and the product management, along with various meteorological tools, including white light, blue light, and laser scanners for inspection and reverse engineering. Now we can get into what's new in ST8. The main focus is design without boundaries. Every year, Solid Edge is updated so that you can be as efficient as possible. This year brings Solid Edge ST8, and it's all about designing without boundaries. ST8 is a uniquely powerful and accessible 3D design portfolio coupled with an amazing user experience, allowing you this freedom. The product we'll be working around is the one you see on screen, the Armadillo from customer RoboSynthesis. RoboSynthesis is a multidisciplinary technology development team based in Taplow, UK, whose primary product features modular, reconfigurable, and scalable robot systems. So what we're going to look at is unique power, its unleashed accessibility, and the amazing user experience on offer. The Like Me pattern recognition. The enhanced pattern recognition for any collection of faces can be run multiple times on the same part, extends reuse and editability of the import parts. The uniquely powerful. Our company uses 3 different CAD systems across multiple locations, so reuse of 3D data from these formats is vital. Synchronous technology within Solid Edge greatly facilitates use and modification of this imported data while avoiding lengthy and costly redesign. The synchronous technology, design intent. New design intent interface, previously called live rules. The heads-up panel. Spend less time learning and understanding, more time designing. More predictable geometry edits. Next, we have the helical curve. Previously, the helical curve was quite cumbersome. There was a lot of options that it demanded the user to fill in. They've modified the helical curve dialog box to be more user-friendly. The easy helical curve creation, the constant variable and compound, you can use for other features such as swept. The pattern by table. You can use the pattern by table using a spreadsheet, particular or irregular ways, not just rectangular or circle, and link patterns together from different options to different options. You can use the link patterns together option to control different features like multiple bolt circles, multiple hole patterns, multiple hole pattern configurations, and it can be done in a spreadsheet and not just in Solid Edge. And you can import this data, and Solid Edge will populate your hole table, and it will populate your model for you. The greater assembly and productivity. Top-level filter to find files quickly. Automated missing file replacement with recursive searching. Reuse top-level sketches for flexible in-content design. Now we have enhanced welding. Apply weld beads as a part for greater welding flexibility. Streamline process for duplicating weld beads across multiple parts. Easily extract property information in a drawing, symbols, and costing. Enriched digital mockup. Enhanced path relationship options. You have variable table monitor for improved visualization. You have an adjustable assembly override, providing more control of subassemblies. One of our customers, Bruckner, experiencing the advantages subassembly relationship override brings, enabling them to focus on the design, not the software. IFC for BMI. Direct translation to IFC to confirm to your industry derivatives. IFC 2x3 and IFC 4. Geometry simplification compatibility. Bidirectional support. Enhanced drawings. Advanced dimensions and annotation handles. New interface for easier format values. Unique parts list and ballooning for subassemblies. Great for large assembly drawings. Linked property and reference text in the text boxes for automation. Flexible thread dimensioning. Technical requirements text. These are all just enhancements just in the drafting. As you can see, there's many different modifications that have taken place in ST8. And inside of this Tech Tuesday, we won't be able to get into much live demonstrations. So what my goal is to just bring these modifications to your attention, and I'm going to show you a few pre-recorded videos, and then later on in some of our future Tech Tuesdays we can get into some more detail on these specific modifications. We also have the drawing compare tool. It quickly and easily compares drawings. Interactive interrogation with color coding for clarity. Save comparison for future reference. This helps drastically in your ECO. Instead of you getting a model and wondering what has changed, you can run through the drawing comparison and you can see exactly what has changed. And with highlight and color coding for your clarity, the changes pop out and you can visually see them. Customer Valve Hydro, experiencing the advantages of drawing compare, provides enabling them to cut time and costs. The enhanced electrical import. Immediately know when multiple occurrences of the same connectors are present. Quick and easy selection of the correct occurrence. Visual feedback of important validation. Enhanced electrical routing. Persistent PMI for efficient routing. Route import cables through clips and other part geometries for accurate packing. Split and reuse existing paths to easily create custom bundles and cables. Splice wires and cables to fully represent any wiring schematic. Enhanced electrical documentation. Cut list and connector list support for new splicing and harness split capabilities. Scale nail board harness for documentation. Simulation topology meshing. Automates larger elements on large faces and smaller elements on smaller faces. More node and elements, only where important, improves accuracy, reduce solve time. As we all know, the more triangles you put on the meshing you put, the longer the analysis is going to take. The way that the new ST8 handles this is it gives you the ability to make larger topology and smaller topology in smaller areas so that your analysis is more accurate for what you need it, instead of one uniform scale of meshing to be applied over the part. This allows for much more accurate analysis with less analysis time. And that coming soon, There's a great tool for Solid Edge called CamWorks for the CAM computer-aided manufacturing software. What you see is what you get. With G-code-based machining simulation, use a third-party machining simulation engine called Eureka from Roboris. All of the machining moves are exactly what the NC machine will do, because the engine is reading and acting on the actual G-code as output. Other systems only display what they think will happen on the machine tool. G-code-based simulation means you know what will happen at the machine tool. This is an extra cost option not provided with any standard package. Because the machine controller combination must be verified by geometric before delivery. NX Cam Express also has this ability. Quick face selection by color means that instead of manually picking faces for machining, you can now filter by color. This is very helpful when machining parts with lots of faces, like mold and die machining. Before model casting input, reducing possible air cutting times, sometimes the raw stock is not cube or cylinder. Sometimes the raw stock to be machined is a casting, or the raw stock has already had several machining operations performed. This new option allows the user to select a complex model as a raw stock. More efficient tool assignment during the new operation creation. CamWorks does a better job of choosing the most efficient size tool for maximum productivity. Sometimes before, CamWorks would select a very small tool for a large pocket. Now it does a better job of selecting the right size tools. Tool crib priority for milling, aiding tool standardization. Before, CamWorks could pick from the list of tools designed for that machine. From the available tools, if a shop did not have the selected library tool, the NC program had to manually select a new tool from the tool crib. This new option allows the user to force the tool selection engine to limit its choice to the tool crib, even if the tool is not optimum for the job. Optimized Tech Database is the project that Mark Bissell has worked on at Dave Allnutt's insistence. The TechDB database has been rewritten to do a better job out of the box for most job shops. Enhanced PMI data transfer, including whole data. Using JT, we now transfer much more product manufacturing information from Solid Edge to CamExpress. JT is our go-forward platform for data transfer between these two products. Optimized roughing routines. CamExpress now has improved performance for rough milling, cut regions for rest milling. Rest milling is the art of re-roughing an area with a smaller tool. Use a bigger tool for most of the material, and then progressively smaller tools to reach areas that the larger tool could not access. We can now limit the area to be searched for rest milling by applying a cut region. Hole chamfer milling tool in operation. Milling chamfers on holes is easier than ever with a new tool defined just for that purpose, and a new hole chamfering operation. Blade or impeller swarf cutting improvements. We continuously improve our impeller machining strategy, and in this release we have added new options for swarf cutting, cutting on the side of the impeller blades with the side of the tool. Group feature enhancement for drilling. More filter tools have been added to allow the user to quickly and easily find a group together holes for common machining operations. Design management with Solid Edge Insight. The SharePoint 2013 support, improved support for massive assemblies using simplified assemblies, SharePoint shortcuts for Solid Edge command. Examples are the insert part, lifecycle assistance, and revision manager. Design management with Solid Edge for SharePoint. SharePoint 2013 support, simplified creation and delegation of links, easier access to design data, quick find, mini browser added to the preview properties card, expanded lookup support, extended access to design data, download copies, extended package file creation, files from an entire assembly to share externally, new publishing tools for workflows, generated and signed PDF, translation files, and file platforms. or patterns. Design management with Teamcenter integration for Solid Edge. You can launch Solid Edge from Active Workspace web client, balloon drawings with Teamcenter Find Numbers, automatic part and revision numbering enhancements, Teamcenter and Teamcenter Rapid Start 10.1.4 support for quick implementation. The design without boundaries, accessibility unleashed. Often when people talk about accessibility, you will hear them talk about the cloud. This is a big buzz world today, and some would tell you to run your CAD in the cloud, or you can't run it at all. And that just doesn't seem right. Why should you decide where your CAD is? Our point of view is different. We know CAD on your desktop is a good thing. That is why you have today, and you rely on it for your business. Is CAD in the cloud a good thing? We think that should be up to you, not us. And so we offer Solid Edge on a trial basis, in the cloud, streaming to your desktop, right now. Not some partial version that does not do sheet metal or weldments or drawings to ANSI and ISO standards. Full professional strength Solid Edge right now streaming to your desktop, be it an Apple Mac or Microsoft PC. Now at this point, this is a trial only in the US and the UK because I said the Solid Edge philosophy is not to force you in some irreversible direction. We think desktop CAD is really productive. Is streaming CAD productive for you? You tell us. Try it right now and let us know what you think. Following from the cloud CAD, which is often advertised as anytime, anywhere, that sentence isn't quite complete. It should be anytime, anywhere there is an internet connection. So we have to remind you about this for true design mobility. Full Solid Edge on Microsoft Surface Pro tablet. Mobile access to full 3D CAD sessions, not watered down. Interact with the click in Surface type cover, mouse and Surface Pen. Finger gestures for view manipulations, pan, zoom, and rotate. Solve engineering problems and collaborate more effectively anytime, anywhere. Beta customer has to say, entire design loaded, ready to talk with manufacturing teams on the spot. Solid Edge and the Surface Pro 3 tablet is very handy for supporting our users. I like the portability of the tablet and the ability to carry this lightweight, compact tablet to the factory floor with the entire design loaded, ready to talk to the manufacturing teams on the spot. Solid Edge Mobile Viewer, the new app supporting Windows 8.1, Microsoft Surface App Store, drawing and modeling view, ghost mode for quicker show and hide, camera backgrounds for the models, new modern user interface, common file for Android and Apple. Something you may not be aware of is Solid Edge by subscription. We offer a monthly basis, manageable, regular cost, several plans to suit your needs, includes maintenance and support, accommodate changes in production demands by adding license when needed, perfect for contract help and interns, tailored for small to medium-sized companies. Solid Edge App Work Marketplace, online shopping for Solid Edge partner apps, easy online shopping experience, enhance partner productivity, product visibility. Siemens software partners can list Solid Edge related apps, support and maintenance for products provided by ISV. The last, amazing users experience. Already available in Solid Edge is great user assistance. Context-sensitive help includes simple procedure, often includes instructional videos designed to give you information on the fly, optimizing your productivity. And also, be aware of Solid Edge Learning Portal. Find it on the start page, learn in different ways, your experience, what you want to do, and what you want to know. Solid Edge Community Live Feed, real-time feed available from the tab on the right of the screen. Stay current on tips and tricks, communicate with users and Siemens experts in the world over while you work. Solid Edge for Facebook feed. You have a real-time feed available from the tab on the right of the screen. Stay current on tips and tricks, communicate with users and Siemens experts in the world over while you work as well. Moving during install. The web installer will play an instructional video while package is being downloaded and installed. For subscription and evaluation users, improved download experience. Download time is productive. No more twiddling your thumbs while it downloads. So that was design without boundaries. So you can schedule update training today through CamLogic. And I thank you for viewing. Now I have 3 videos for you to watch that help highlight some of these modifications.
Products are designed as a whole, not just the individual components. This translates in CAD as the ability to easily edit parts at an assembly level. Here we have a solid edge assembly of a custom pulley system where we want to make changes to the width to fit a wider belt. Of course, this means editing several components. First, we'll approach this as you would in most any other CAD system, using history-based editing. Then, we'll take a look at how synchronous technology can help us out. So, history-based first, and let's start with the pulley itself for the initial edit. Notice the list on the left. This is the history-based recipe of features that make up this part. It can be tricky finding which feature is the one that we want to edit. However, Solid Edge does assist us by picking up the relevant feature after we click on the model in the graphics area. So let's take this 35mm dimension and change that to 55mm. Simple. Oh, no, wait. Because this is history-based editing, there are dependent features further down the tree on the left that this has caused issues with, damaging our model. So we need to go back and work out how we can make our desired width change another way. It turns out that we need to make multiple edits to not very obvious features in a particular order. Okay, done. So, back at the assembly level, obviously the wheel is now wider, which means it's interfering with the other components. And we have some internal parts to deal with too. Now to modify these, we could continue using a history-based approach, editing each individual part. However, this is time-consuming, as you've seen. We could set up links between the parts so that a change in one part updates another. However, this too takes time. We want something instant that doesn't have the overhead of interlinking. So let's turn to synchronous technology. First, notice we're staying at the assembly level. From here we can simply pick a face and drag to edit. And Solid Edge is intelligent enough to know that this is a symmetrical part, so we probably want to keep it as such. But ideally we want to make several edits at the same time. Let's see how this works by selecting multiple faces from multiple parts. Here we can modify not just 1, or 2, or even 3, but let's edit 4, 5, and 6 different aspects from 4 individual parts. And still, Solid Edge is automatically seeing that this design is symmetrical, so actually it's doing double these edits for us. And also notice how everything else is changing sensibly. Tangent relations and wall thicknesses, for example, are all being maintained. That's what we mean by one-shot multi-part editing. Another way to make one-shot multi-part edits is by aligning faces, again all at the assembly level. Let's take the back side of these brackets and align those together. Nice and easy, just click the first face from one part, and the second face from the other part, and done. We could even take this a step further by asking Solid Edge to find all of those coplanar faces that we've just been working with, then get those snapped to this back face here. Just as easy, done. So there you have it. No more in and out of each part with multiple time-consuming history-based edits, or even the need to interlink. Synchronous technology in Solid Edge allows one-shot multi-part editing, all at the assembly level. Solid Edge, design better. Reuse and repurposing is of course the preference over recreation, whatever the subject. It saves time and effort. In CAD, this usually translates to importing data and working with the whole model. However, synchronous technology in Solid Edge also allows you to reuse individual design details. In this example, we're going to create a custom fuel adapter starting with a basic body and then simply reuse design details from other Solid Edge projects to complete. First, so that we know where our output ports are going to go, we'll quickly create a few holes. And notice how quick we can space these, no separate dimensioning tool required. Now for the barbs, and this is where we can save lots of time and effort. I know that we've created geometry like this before on another project, this blue component, so why not reuse this detail rather than waste time modelling from scratch? We simply select the detail we wish to use. The well-known Windows Fen Select saves a lot of time here. Oh, and notice that we're moving what we call the steering wheel to a specific position. This is our main control for synchronous technology, and here it'll help us locate the detail in our new part. Then simply click Copy, or use the Windows Control-C shortcut. Back in our custom fuel adapter, we just paste it in, again using the Windows shortcut Control-V if you like, and you can see our steering wheel is just where we left it, so placement becomes the simple task of snapping into place. And if you think you'll be using this detail again in the future, you can just store it away in the library. All you have to do is open your library pane and paste it into here instead. To reuse it, just drag and drop. The steering wheel can also be used to enter precise offset values. Here we'll offset it exactly 15mm and then snap the barb into place. Additionally, by holding down the Control key while we drag the steering wheel, we can copy this barb to the other location required. Again, notice the familiar use of Windows shortcuts. Holding Control in Windows does the same thing, copies, quick and easy. Now that we have the barbs in the correct location, we need to figure out how we're going to attach the geometry to the part. Luckily there's no need to worry about such things as Boolean operations, as Solid Edge will take care of this. Watch as it automatically extends to connect to the solid geometry. But what happens if we realise after pasting these barbs that we want to move them, perhaps to help hose clearance? No problem, we can use the steering wheel at any point in time to make required mods. Let's quickly add an angled offset here to the top and bottom connectors. Now that we have the output side of this fuel adapter finished, let's take a look at the fuel flow sensor side. Again, we have the basic geometry here. However, rather than modelling the internal sensor housing detail, let's also reuse this 3D detail from another project. The housing detail is already in our library, so all we need to do is drag and drop like before, and again use the steering wheel for placement, this time ensuring central alignment. Notice that when reusing 3D detail, not only can features add geometry to parts, but they can also remove geometry at the same time. Furthermore, Solid Edge will also bring through design intelligence. For example, here the holes aren't just cylindrical pieces of geometry, they're real holes, so we can accurately modify them to suit. And as for this cutout, a key dimension has come through so we know to tweak for our requirements. Now that our custom fuel adapter is finished, let's complete the assembled unit by adding the sensor. Of course, here we're reusing a whole model rather than specific 3D detail, but still Solid Edge helps us out by reusing the assembling detail, its positioning references, to accelerate placement. In summary, we were able to precisely create our new component in just a couple of minutes, all thanks to synchronous technology in Solid Edge. It allowed us to easily reuse 3D detail from other models with just a simple copy and paste. And remember, this 3D design detail can be reused from not just Solid Edge files like we had here, but from non-Solid Edge CAD data too. Solid Edge, design better.
Solid Edge delivers intuitive tools for complex shape construction, a must for designers of ergonomic and aesthetically pleasing consumer products. Here we have a kitchen appliance from one of our customers, Tefal. To demonstrate Solid Edge's capabilities, we'll redesign the rear panel of this domestic fryer to eliminate physical interference between its cooling fan and the rear casing. An industrial designer has modified the rear panel in conceptual sketches, so we'll display these in Solid Edge. This new design accommodates the repositioned fan while also providing a handhold to easily lift the fryer. We'll use this collection of sketches as a template to guide curve creation, ensuring we closely match the designer's vision for this part. Solid Edge allows us to generate a free-flowing yet customizable curve with a minimum of control points, yet drag any point and completely change the shape. In this case, we'll design one half of the new feature and then mirror to complete the design, so we'll connect the endpoint of the curve to the part's midline. Here we'll use two pre-existing sketches placed relative to the top and bottom in the industrial design sketch. Once again, we'll draw a curve to match the side profile of our template and connect the endpoints to these upper and lower sketches to define the exact start and endpoints for the final feature. We drag control points to replicate the conceptual shape. The cross and guide curves must be connected to create a successful surface feature, and Solid Edge Blue Dot does the job. We'll extrude this curve to create a construction surface for controlling tangency across the midline of a symmetric part. Blue Surf within Solid Edge enables us to loft a surface between the three curves while guiding its shape with the edge of the construction surface. Individual tangency controls ensure that the Blue Surf is tangent continuous with the construction surface and thus the mirrored face. Our next task is to trim away part of the surface we don't need. We'll project onto our surface an existing curve based on the conceptual sketch. Simple and fast. To complete this rear surface, we'll stitch together the two halves. The ruled surface command extends the edges through the existing casing part. Advanced rounding really aids aesthetics, so we'll place a constant width round along the edges. Next, we'll use surface body by boundary to cap off the inside of the surface body. Stitching these two faces will form a solid body that we can use to punch or emboss the original part. Simple and fast. We can finish the design by rounding the resulting edges. Since our design goal is to make space for an exhaust fan, we need to build in a vent. The vent tool constructs a customizable series of ribs and spars in an array using any basic sketch. Imagine creating this complicated feature with traditional cutouts and extrusions. Creating complex shapes in Solid Edge is easy, yet smoothness and flow of the final plastic is of utmost importance. In this part, we have 6 individual faces along the top. The Zebra Stripe visual inspection tool helps. Note that the zebra stripes reflect jagged transitions across the patches, so we'll use the Redefine tool to merge the 6 patches into one beautiful and continuous surface. Now that we've seen some powerful surfacing tools in Solid Edge, watch as we create complex geometry utilizing multiple solid bodies. This fryer uses a stirring paddle to ensure an even distribution of cooking oil throughout the food, so we need to design an arm coming off the paddle's mounting hub. To begin, we have a top view sketch of the arm's shape and a side profile sketch depicting how the top of the arm curves away from the center mount. We'll combine these sketches to generate a resulting cross curve of their virtual intersections. As we create a series of profiles through which we can create a lofted feature, we'll use the pre-existing curves to guide the feature's transition through the cross sections. At any point, we can make a change to the defining cross-section profiles. Watch how the complex lofted feature dynamically updates. In this case, we want to retain the original design. To finish this arm, we'll place a constant width rounds on the top edges. The end of the paddle is a proven design that we're simply going to integrate into our paddle arm. Watch as we use the Replace Face command to trim away the end of the arm body. Our final goal is to hollow out the paddle's face. A Replace Face option allows us to add a cross-section sketch which we can pull inward. That was easy. In this demonstration, we've proven that Solid Edge provides a broad collection of surface and solid modeling tools, perfect for creation of complex consumer products. Solid Edge. Design better. Solid Edge delivers intuitive tools for complex shape construction, a must for designers of ergonomic and aesthetically pleasing consumer products. Here we have a kitchen appliance from one of our customers, Tefal. To demonstrate Solid Edge's capabilities, we'll redesign the rear panel of this domestic fryer to eliminate physical interference between its cooling fan and the rear casing. An industrial designer has modified the rear panel in conceptual sketches, so we'll display these in Solid Edge. This new design accommodates the repositioned fan while also providing a handhold to easily lift the fryer. We'll use this collection of sketches as a template to guide curve creation, ensuring we closely match the designer's vision for this part. Solid Edge allows us to generate a free-flowing yet customizable curve with a minimum of control points. yet drag any point and completely change the shape. In this case, we'll design one half of the new feature and then mirror to complete the design, so we'll connect the endpoint of the curve to the part's midline. Here we'll use two pre-existing sketches placed relative to the top and bottom in the industrial design sketch. Once again, we'll draw a curve to match the side profile of our template and connect the endpoints to these upper and lower sketches to define the exact start and end points for the final feature. We drag control points to replicate the conceptual shape. The cross and guide curves must be connected to create a successful surface feature, and Solid Edge Blue Dot does the job. We'll extrude this curve to create a construction surface for controlling tangency across the midline of a symmetric part. BlueSurf within Solid Edge enables us to loft a surface between the three curves while guiding its shape with the edge of the construction surface. Individual tangency controls ensure that the BlueSurf is tangent continuous with the construction surface and thus the mirrored face. Our next task is to trim away part of the surface we don't need. We'll project onto our surface an existing curve based on the conceptual sketch. Simple and fast. To complete this rear surface, we'll stitch together the two halves. The ruled surface command extends the edges through the existing casing part. Advanced rounding really aids aesthetics, so we'll place a constant width round along the edges. Next, we'll use surface body by boundary to cap off the inside of the surface body. Stitching these two faces will form a solid body that we can use to punch or emboss the original part. Simple and fast. We can finish the design by rounding the resulting edges. Since our design goal is to make space for an exhaust fan, we need to build in a vent. The vent tool constructs a customizable series of ribs and spars in an array using any basic sketch. Imagine creating this complicated feature with traditional cutouts and extrusions. Creating complex shapes in Solid Edge is easy, yet smoothness and flow of the final plastic is of utmost importance. In this part, we have 6 individual faces along the top. The Zebra Stripe visual inspection tool helps. Note that the zebra stripes reflect jagged transitions across the patches, so we'll use the Redefine tool to merge the 6 patches into one beautiful and continuous surface. Now that we've seen some powerful surfacing tools in Solid Edge, watch as we create complex geometry utilizing multiple solid bodies. This fryer uses a stirring paddle to ensure an even distribution of cooking oil throughout the food, so we need to design an arm coming off the paddle's mounting hub. To begin, we have a top view sketch of the arm's shape and a side profile sketch depicting how the top of the arm curves away from the center mount. We'll combine these sketches to generate a resulting cross curve of their virtual intersections. As we create a series of profiles through which we can create a lofted feature, we'll use the pre-existing curves to guide the feature's transition through the cross sections. At any point, we can make a change to the defining cross-section profiles. Watch how the complex lofted feature dynamically updates. In this case, we want to retain the original design. To finish this arm, we'll place a constant width rounds on the top edges. The end of the paddle is a proven design that we're simply going to integrate into our paddle arm. Watch as we use the Replace Face command to trim away the end of the arm body. Our final goal is to hollow out the paddle's face. A Replace Face option allows us to add a cross-section sketch, which we can pull inward. That was easy. In this demonstration, we've proven that Solid Edge provides a broad collection of surface and solid modeling tools, perfect for creation of complex consumer products. Solid Edge. Design better.
Once again, my name is Mark Anderson with CamLogic. I want to thank you for watching this episode of Tech Tuesday. Please don't forget to schedule your update training with CamLogic and join us again for more on what's new in ST8. Thank you.